Example 6, solving a multi-step problem. It's about volume. A crate in the shape of a rectangular prism has a volume of 180 cubic feet. The crate has a width of W feet, a length of the quantity 9 minus W feet, and a height of W plus 4 feet. The length is more than half the width. Find the crate's length, width, and height. So our first step is to write and solve an equation for W. So first we have to think about how do you find the volume of something like a crate. It's a rectangular prism, so that would be length times width times height. So just pulling things out of the equation, they gave us a volume of 180 cubic feet. They gave us a length of the quantity 9 minus W, a width of W, and a height of W plus 4 feet. So we're going to use that to rewrite this as a polynomial equation that's set equal to 0. So I'm going to have to multiply my dimensions together, my length, width, and height together, and subtract 180 from both sides so that this equation is set equal to 0. Now I'm going to move over to the side and do my multiplying. I really can only multiply two things at a time, so I'm going to take the first two dimensions, the length and the width, and multiply those, just using the distributive property like we always do. So 9W minus W squared, that was the length times the width. Now I've got to multiply that by the height, which is W plus 4. Now this involves two binomials, so I'm going to use FOIL to do that. 9W times W, the first would be 9W squared. Outside, 9W times 4, positive 36W. Inside, we have a negative W squared times W, so minus W cubed. And the last, 4 times negative W squared, so minus 4W squared. So I've multiplied my dimensions together, length, width, and height. I'm just going to see if there's anything I can simplify. I do have some like terms here, 9W squared and negative 4W squared. So if I combine those, now I've got 5W squared plus 36W minus W cubed. So if I put that back over here and I subtract 180 from both sides, I would have 5W squared plus 36W minus W cubed minus 180. So I've got 4 terms in my polynomial. When we have 4 terms and we're trying to solve, the first thing we do is group terms together in pairs. Now as I look at the order of my terms right now, I can't just group them the way they are because I don't see a common factor between negative W cubed and negative 180. So I'm going to swap things around. I know for sure that 36 and 180 would have some common factors. Even just 2 and 6 come to mind. So I'm going to rewrite this in a different order. 5W squared minus W cubed, because I know they have W squared in common, positive 36W negative 180. Those are going to have common factors as well. So I'm going to group those and see what I can do for factoring things out. Well, again, W squared is a common factor for the first binomial, or the first pair of terms. So I'm going to factor that out, W squared times 5 minus W. That's how that would factor out. Over here, I know that 36 and 180 have common factors. I just don't know what the greatest one would be. So I'm going to mess around a little bit off on the side, or the bottom here. I'm going to take 36 and I'm going to take 180, and I'm going to break them down into their bare bones by using prime factorization. So for example, 9 times 4 is 36, 2 times 2, 3 times 3. So I'm seeing the prime factors of 36 are 2 times 2 times 3 times 3. Now 180, oh, let's see, 18 times 10, 2 times 5, 9 times 2. All right, so I've got 180 broken down, and it would be 2 times 2 times 3 times 3 times 5. So there are the bare bones of 180. As I look at both numbers, this is 36, and 36 is right here in the prime factorization of 180. So it looks like 36 times 5 is equal to 180. So I'm going to use 36 as my greatest common monomial factor here. So factoring out 36, I will get W minus 5. Now that is the opposite of 5 minus W. So I'm going to make one change. I'm going to change this to negative 36. So one more time, W squared times 5 minus W plus negative 36 times 5 minus W. So if you think about that, going backwards, negative 36 times 5 would be negative 180. Negative 36 times negative W, or the opposite of W, would be positive 36W. So this does factor out to this. It just wasn't the first thing I thought of. So now I've got a common factor here, 5 minus W. So I can factor this into W squared minus 36 times times 5 minus W. There's one last thing I need to do, and I'm out of space, so I'm just going to do it over on the side. I need to take one last look at what I've got, and I see something special here. This is the difference of two squares. Sometimes we forget to look for that. The difference of two squares can be factored to the sum and difference pattern. So I'm going to think about, what did they square to get each of these numbers? They squared W here, they squared 6 here. So this would have factored to W plus 6 times the quantity W minus 6. So the entire polynomial factored out to W plus 6 times W minus 6 times 5 minus W, which means I could have, and it's all equal to 0. So I could have three different values for the width right now. If W plus 6 equals 0, then W would have to be negative 6. If W minus 6 was equal to 0, then W would have to be 6. If my third factor, 5 minus W, was equal to 0, it would have to be the width would have to be 5. 5 minus 5 equals 0. So we have three possible widths right now. Right away I can see that if we're talking about the width of something like a crate, a negative number is not going to make sense. So one thing we are going to do is eliminate this solution. It's a solution for the equation, but it's not a viable solution for the problem. I'm going to stop here and do step 2 in the next video.